Hello and welcome back everybody to MAN471. My name is Roland and these are the slides I used when teaching fundamentals of project management at International Business School in Suzhou between 2017 and 2019 when I resigned. In our 10th session, I looked at reducing the duration of the project and was running a couple of exercises with the students in order for them to get a feel and learn the technique of what you can do in order to reduce the duration. Now, first of all, why would you want to do that, reducing the duration of the project? And the two main reasons that we've discussed was, first of all, the reason is you want to catch up with the project because there has been delays throughout the whole course of the project. And reducing duration of the remaining activities would then get the project back on track and into the timeline. The second and very important reason is that you absolutely must be the first in the market with a new product. For example, when you learn that a competitor is releasing a similar product or a competing product in the same price segment, you want to be the first in the product. And in no other area than mobile phones is this more true, because the first one to the market is the one that takes the lion's share of the sales. And it is so crucial that a delay by even 1 or 2 weeks will completely ruin a phone release. So phone companies like Apple and Samsung are trying to beat each other to the market with their latest flagship phone. So when we were looking at the whole project, this is the first example I gave students, and the first task was obviously to draw the activity network for the project and then look at the whole project in terms of which activity would you want to shorten. And the hint was activities B and H can be shortened to a minimum of 2 weeks. So the question is now, which activity would you shorten? And when drawing the activity network, you see that H is the only one that is on the critical path. So it doesn't make sense shortening other activities that are not on the critical path because they do not contribute to shortening the actual project. As we discussed in last session or the session before the outsourcing session, if you look at the project network, there is a red line that goes through the project of activities that follow one after the other logically and create this so-called critical path. And if you shorten any activity outside that critical path, it won't affect the project duration because the critical path is the project duration. So looking at the second exercise, I asked students to use the information in this exercise to compress the project by 1 time unit at a time and then identify what have they actually crashed, why have they crashed it, and what is the cost of the project after that. Initially, we are starting with a project duration of 12 days. As you can see, activity A, 1, which is already fully crashed. C, E, and F are the critical path. Going 1, 4, 4, 3, which leads to 12 days of duration. If you follow the A, B, D, F path, this is only 10 days. So the first thing we need to do is crash on the critical path. So C, E, and potentially F are up for this exercise. And when you look at the crash cost, you're looking at C would cost you 50 currency units to crash, E would cost you 70, and F would cost you 90. So you want to minimize cost in this exercise as well as shortening the project as much as you can. So the first one is obviously going to change activity C because it has, as we have seen, the lowest crash cost of 50 currency units. The project is now 11 days long, as you can see on the top left. It costs additional currency of 50 units, and we still have the critical path A, C, E, and F. Our next crash would be activity E, which costs us 70 currency unit for a time of 10 and a total direct cost of 1,120 after all the crashes. Now what you can also see is we now have two critical paths, which is key to the exercise. We have one critical path going 1 day at A, 3 at C, both are fully crashed, E at 3 days and F at another 3 days. The same length in project duration can be achieved by A, B, D and F. So now we see we need to crash either E on the critical path at the bottom or B and D at the top to achieve a 1-day reduction. Alternatively, we can crash F for another reduction, and F is on both critical paths as the end point. Obviously, we are going to crash F for a cost of 90 with corresponding total direct costs of over 1,200 now. Going further, we need to crash both activity D and E for an additional cost of 130 and running up to 1,340 currency units with a maximum crash of 8 days. We could crash B, but it would not contribute to actually shortening the project because everything else is already crashed to the maximum. In the second exercise, and I'm going to take myself out of the picture for a second, we assume the following network and the data, computing the total direct cost for each project duration if we crash every single activities that can be crashed. Now, in this exercise, we are adding the concept of indirect cost, which for the project duration are 400 at 19 time units, 350 at 18, 317, and so on and so forth. Now what you can see immediately is that while the indirect costs are reducing, the direct costs on the right hand sides are going to increase obviously. So we can now play around with the time in order to achieve the optimal outcome and the optimal cost structure for this project. Now, when we are going about doing it like this, the first thing we are doing is we are writing our project network with a total initial project duration of 19 time units. The total direct cost correspondingly the total cost of all activities, and we identify the critical path of A, B, E, and G. So the first thing we are doing, we are crashing the critical path to 18 days, which adds 50 currency units to the cost of 470, running to 530. Now, crashing further, as you can see, activity A is creating another cost of 20, which then goes to 550. Now we have still the same critical path, and the paths B, E, C, F, and D are already at 10 days, which means we can't crash any of these activities, D already being crashed to the maximum. So we need to look at A and G. And now we are crashing G for a total project duration of 16 days and total direct cost of $620. Looking at the critical path and moving through this whole exercise, obviously we start crashing by the lowest cost or biggest bang for lowest buck, and that would be E. And then we have, as I said, 3 chains of equal length exactly 10 time units. And then we need to shorten these together at the same time at the corresponding cost, or look at the activity A and G, which are the starting and end points. So we cannot shorten D, so we can only look at A or G. Crashing A at a cost of 20, then crashing G at a cost of 70, we come to the project duration of 16 and total direct cost of 620. And putting all this data into an overview, we can look at the cumulative costs of direct cost plus indirect costs, and we can see crashing the project 2 days will give us a total cost of 850, while every other activity, whether it is the original project or any crash, would leave us with cost way above these 850. So you can see crashing can actually reduce the total project cost, and when we experiment with different crash scenarios, we can find the optimal cost structure for the project. In this session, I then went on more about the effect of shortening the project duration, looking at how difficult is it exactly to make this kind of decision, using the example of the mobile phone market, and running through even more exercises with students to give them a lot more experience in terms of what can I crash, when do I crash, and what are the risks of crashing the project. There is other considerations to take when we are talking about shortening the project, because how are we going to do it? We need to add resources. For example, we could be working overtime, and we can have a look at what is the effect of authorizing overtime. It's not all positive, so while you have experienced people on the project that simply work more and consequently cost you more money, the absence of a fresh pair of eyes is unlikely to solve the problems that have led to the situation. So it's always a balance of how you are approaching this kind of duration dilemma when you are looking at, do you just add resources or do you do something else? Thank you very much for your attention. See you the next time.